Hello everyone, welcome back again. So now in the last segment we saw two example of finding truth table of two compound statement. So you know that now having some elementary statement, by using them we can really create a long messy statement. We can use a lot of conjunction, disjunction, negation, implication, and we can really create a long statement. Okay, now even though a statement is very long, finally actually each statement will be evaluated to either true or false. Okay, so the thing I'm trying to say is that one statement could be very long, but there could be a simpler form of a compound long statement. So two statement having two different statement, they are knowing as logically equivalent if they have the same truth value. Okay, so the thing is that no matter what is the format of your statement is, at the end each statement will be evaluated to either true or false. So having two statement, let's say you have two statement A and you have another statement B. Okay, at the end, if two statement if these two statement has the same truth table, so for each combination of true and false, if the two statements generate the same truth table, they are known as a logically equivalent. And if they are logically equivalent, in that case we use this symbol, okay, to say that these are two statements and they are logically equivalent. Means that no matter what is the format of this statement is, at the end they both are going to generate same truth table. So let's see just one very simple example. Okay, let's see we have a statement P. All right, just a very elementary statement P. All right, so the value of P, it can be either true or false. All right, uh, now I'm saying another statement. So this statement, it's a statement, let's say A. So it's just one statement P. The value of P can be true or false. So another statement, I'm saying that that's a not P. Okay, so not P, what does that mean? So double negation means actually it is going to cut off each other. So double negation means actually it is same as P. Okay, so P not P means it will be false, it will be true. Then let's see, I have another statement not P. Okay, then not P means not of this not P, so this will be true, false become true, true become false. All right, now if we check the truth table of this statement and the truth table of this statement, they are logically equivalent because their truth table is same. All right, so in that case we can say that okay, so two statements are logically equivalent if they have the same truth table. Okay, so just think about with your real English word, say I like rice. Okay, so that's a statement. Let's give this statement a name P. Okay, so then not P will be I do not like rice. Not P means I do not like rice. Okay, so then not P would be it's not true that I do not like rice. So it should be like that. It's just a more complex, but the meaning is actually same. So it's not true that I do not like rice. or you can say that it's not the fact that I do not like rice. It's not true that I do not like rice. Means actually I like rice. So these two sentences, they have the same meaning, just we are saying that in a different way. This is just a more complex way to say that, and this is just a simpler form of expressing the same meaning, but they are logically equivalent. Okay, so here the idea is same. We can have different format of statement, but if the truth table is same, these two statement will be known as logically equivalent. So let's see another example. Let's see, we have a statement P. Okay, we have a statement P where the statement is, okay, so we have a statement P where we have that's actually capital P and that's a small p. Okay, so not P, not P or Q. Okay, we have another statement Q, which is like not P and not Q. Okay, so let's see whether these two statements are logically equivalent. Their format are different, but let's see whether they have the same meaning. Okay, so one way to do that is finding the truth table. Okay, so let's do that. So let's first do for P. Okay, we have P, Q. Okay, so let's find out P or Q. So true, 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 false. So let's find out the negative of that. So this will be false, 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 true. Okay, all right, that's for statement P. Now let's do that for Q. So we have P and Q. So all right, so let's find out not P. Find out not Q. True, false, true. Let's do the or with them. P, sorry, and. Okay, so it will be false, false, false. The final is true. All right, so we are using the same combination here. Okay, using the same combination, P and Q, using the same combination, you can see that the result truth table of this statement and truth table of this statement is same. Okay, that means actually this both statement has the same meaning. All right, so using the truth table, we can say that P is logically equivalent with Q. Means nor of P or Q is logically equivalent with not P and not Q. Okay, so using the truth table, you can prove that whether two statement is logically equivalent or not. Now the last example we talked about, the last example actually it has a special name. This equation, this statement is known as a De Morgan law. Okay, so it has a special name. It is known as De Morgan's law. So this law says that is logically equivalent with P, okay, or Q, or I can actually do the change like okay. So here it is saying that not P and Q equals logically equivalent with not P or not Q, or not P and Q is logically equivalent with not P and not Q. Okay, so now let's just see one example with this statement with plain English word. So in last segment we actually proved that using truth table that they are logically equivalent. So now let's just see one example using plain English word how they actually means the same. Okay, so let's see P means actually it's a statement. So just a very silly example. Let's see. Say Trevor is unicorn. Okay, and Q is a statement where Trevor is goldfish. So very silly example, but let's see. We can find they mean actually same in a plain English word with an example. So let's P means Trevor is unicorn. Q means Trevor is goldfish. So P or Q means Trevor is unicorn or Trevor is goldfish. Either Trevor is unicorn or Trevor is goldfish. Okay, so it means that either Trevor is unicorn or or Trevor is goldfish. So what is the meaning of not P or Q? So not P or Q will be the meaning, means it is not the case that Trevor is a unicorn or Trevor is a goldfish. Okay, so it is not the case means Trevor is unicorn or Trevor is goldfish. Okay, now let's find out nor P means Trevor is not unicorn. Not Q means Trevor is not goldfish. Then not P and not Q means Trevor is not a unicorn and not a goldfish. So not P and sorry, not P and not Q means Trevor is not a unicorn and Trevor is not a goldfish. Okay, so now if we think about the meaning of these two statements, you can see that it's not the case that Trevor is a unicorn or a goldfish. Trevor is actually none of them. Okay, Trevor is it is not the case that Trevor is either unicorn or a goldfish. Trevor could be none of them. Okay, and not P and not Q means Trevor is not a unicorn and Trevor is not a goldfish. So that means actually same. Okay, so using the plain English word also that means actually same. So here we are writing the same meaning, same sentence in a different format, but the meaning is exactly same. Okay, so this is the idea of the logically equivalence. So we can these two laws are known as De Morgan's law. The second one actually we saw that using the truth table also. So we can just switch the position of and or, but they both are De Morgan's law. So the first one says that not of P and Q equals to logically equivalent with not P or not Q. Okay, and the second one says that not P or Q is logically equivalent with not P and not Q. Okay.